Hello and welcome back, my lovely viewers and my dear students. Today we are going to be working on part 2 of powers of binomial, which will be helpful for grade 9 and 10. So the learning objectives of this video are going to be that you are going to be learning how to expand powers of binomials by using Pascal's triangle and the binomial theorem. Very important lesson. I would recommend each one of you to watch the full video to take the maximum benefit out of today's session. So in the last video, we had seen what is Pascal's triangle, and I would put the link in the description box. If you have not watched that video, I would highly recommend to watch that one before you understand this video. In today's session, we are going to be using that Pascal's triangle to calculate the binomial coefficients. Also, we are going to be learning about the binomial theorem and how it can be used to calculate the binomial coefficients and write binomial expansions. Very important lesson for all my grade 9 and 10 students. So before we dive into the video, let's recall about the Pascal's triangle from our last session. So this is how the Pascal triangle looks like. I hope you all have revised the previous video and revisited before this session. So the special characteristic, as you can observe in this Pascal triangle, is that the corners, the edges are all one. I'm just highlighting once more for all of you. And looking at any row of the Pascal triangle, you could find the coefficients or the numbers in the next one. Okay, so for example, I'm taking this row. So looking at the previous row, so 1 plus 2, if I add these two numbers, I'm going to get 3. If I add the other two, let me change color. 2 plus 1, I'm going to get 3. And similarly, any other row I could get by adding the previous coefficients. Another thing that you should remember is that the Pascal triangle starts from row 0, then row 1, row 2, and so on. Okay, so let's see how we can use this Pascal triangle for the binomial expansion and writing the binomial coefficients. Okay, so let me take the first example here. Very important. I want you to pay attention to the video now. And if you see here, there are two terms to this polynomial. So it's a binomial x plus 3 and it is raised to the power 4. Now if we go to a Pascal triangle, then from the Pascal triangle we know that the binomial coefficients, once we expand this binomial, the coefficients that we are going to get before the variable part will come from the Pascal's triangle. So the power here is n, which is 4. So that means the fourth row of the Pascal triangle is going to help us to get the coefficient. So let me go back and show you the coefficients. So if you go to row 4 of the Pascal triangle, the coefficients are 1, 4, 6, 4 and 1. So these are going to be the binomial coefficients in the expansion of x plus 3 to the power 4. So looking at the power, you can decide which row you will take to write the binomial coefficient. Okay, so let's expand. Now, in general, if it is a binomial a plus b to the power 4, then we can write the binomial expansion using these coefficients 1. Let me just change color here. So this is 1. This is the next coefficient 4, then 6, then 4, and finally the last one 1. Now because here the two terms, the first term is a, the second term is b, and the power n we have already discussed is 4. So when we are writing the variable part, when we are writing the terms with these coefficients 1, 4, 6, 4 and 1, we are going to write them in such a way that the sum is always going to be the value of n. So we start from the highest power. So n is 4. So for the first term a, I'm starting with a4. Then I'm going to decrease a3. One more decrease, negative, you're just subtracting 1 to the power. So a3, then a1 and a0. Okay, we stop at 0. Then we start for the second term. So b is the second term here. We start with the 0 power and now here I'm increasing the power by 1. Now 1 power I'm decreasing, 1 power I'm increasing, so that for each term you may just check 4 plus 0 is also 4, 3 plus 1 is also 4, 2 plus 2 is also 4, 1 plus 3 is 4, 0 plus 4 is 4. So the sum of the powers is 4. That you should always check so that you don't make a mistake. So then again B0, B1, B2, B3 until the maximum value, that is 4. So B4. Now I want you to notice, I've just explained that to you, that the exponents always add up to 4. That's what you need to check. For the first term A, the power is decreasing. You can see 4, 3, 2, 1, 0. And then for the second one, it is ascending, increasing. So now this is the formula for the binomial expansion of a plus b to the power 4. Now just to summarize the question and write our final answer, we are now going to do the substitution. So for the first term, a, the value of a is x in this question. Let me write. First term is a equal to x. Second term is equal to b, which is 3 here. So just substitute wherever there is a, you put x, wherever there is b, you put 3. So let's see what we get after we simplify. So when we are putting the values of a and b, we are getting this simplification. Let's simplify it a little bit more and do the multiplication. So 4 will be multiplied to 3, 6 will be multiplied to 9, 4 will be multiplied to 27 here, and then 3 to the power 4. So you can simplify the final step of the binomial expansion as this. So here we have seen for the first example how to write the binomial expansion using Pascal's triangle. Okay. Now let's do another one. I'm taking example 2 here now. So for example 2, I hope you all can again observe that the power n is same, 4. So what is the difference basically? So here the first term, let's write, is x, and what is the second term? It has a negative sign, not to forget, so negative 2y. So let's just do the same substitution. Because the power is same, the coefficients from the binomial expansion are going to come from the same fourth row. So from the fourth row of the Pascal triangle, you've got the same coefficients 1, 4, 6, 4, and 1 again. The only difference, we have substituted this time a negative value for b. So again, we do the same thing. For the first term x, we have the power in descending order 4, 3, 2, 1, and finally 0. So it's gone 1. And then the second term is starting from 0 till 4. I hope you remember from exponents, any base raised to the power 0 is 1, and that's why you don't see the second term here because it's 1, and you don't see the first term here because it is 1. So let's simplify, and then the final answer comes out to be this. I hope you've understood from these two examples how the Pascal's triangle, how its rows are giving you the coefficients for expanding these binomials. Okay, so let's see another example here where we are going to be using the Pascal's triangle to write the binomial coefficient. So for example, I'm giving you a binomial x plus y to the power 7. This is the binomial that we need to expand, and we need to find the binomial coefficients. So let's use the Pascal triangle first to do the same thing. And after that, we'll also look at the binomial theorem, how we can use for the same question. Okay, so because the power here n is 7, that means we are going to look at the 7th row of the Pascal triangle to give us the coefficient. So you can look at the numbers, the coefficients in the Pascal triangle, 7th row. I'm just highlighting here. Okay, so these are 1, 7, 21, 35, 35, 21, 7, and 1. So let's see how we can expand x plus y to the power 7 using this 7th row of the Pascal triangle. So I'm writing equal to, let me first write the coefficients. 1, 7, 21, 35, 35, 21, 7, and 1. So these are 1, 2, 3, 4, 5, 6, 7, 8 coefficients. Okay, now let's begin with the first term x, and it has to have the maximum power. So the maximum power is 7. So let me give it 7. And for the second term, let me give it a 0 power. Okay. Now what I'm going to be doing, I will be decreasing the power of the first term x. So from 7, it becomes 1 less, then another 1 less, x to the power 4, 3, 2, and 1. Finally, the last term, it ends at 0. Now look at the second term, y. So for y, we are going to be increasing. So y to the power 1 plus y to the power 2 plus y to the power 3 plus y to the power 4 plus y to the power 5, y to the power 6, and last term y to the power 7. So that's the maximum n. Now final answer would be, because any number raised to the power 0 is 1, so it will be simply x to the power 7. Similarly, last term will be y to the power 7. In between, we have 7x to the power 6, y to the power 1, plus 21x to the power 5, y to the power 0, plus 35x to the power 4, y to the power 3, plus 35x to the power 3, y to the power 4, plus 21x to the power 2, y to the power 5, plus 7x to the power 1, y to the power 6, and last term y to the power 7. So actually the question was just asking you the binomial coefficients, but we have done a bit more than that. We have used the Pascal triangle to do the binomial expansion of this binomial. Okay, now in the coming slides, you are going to see that how you can also find these binomial coefficient using combinations. So I will just discuss this part in the next slide, where I'm explaining you how to calculate these binomial coefficient using combination and factorials. So let's see that. So now we are going to dive into binomial theorem. That's the next learning objective. And as you can see, this theorem can also help you to get the binomial coefficients. But yes, this binomial theorem and using the binomial theorem to find the binomial coefficients is a much lengthier way of expanding the binomial or getting the coefficient. So here, as I explained, we are going to be using combination. So NCR. This is one notation of the combination that you can use. The second way to write will be NCR, and the third way is these big brackets and then N and R. I hope you remember from your lower classes that N will be more than R always. So we are taking R combinations out of N by this formula. So just I'll put a star mark here, very important. This formula of combination will also help you to get the binomial coefficients, and then using the binomial theorem, you could also do the expansion. This is just another way of doing the binomial expansion, but you are going to be getting the same answer for the binomial expansion whether you use the theorem or whether you use the Pascal's triangle. So let's now see, I have here 3 examples for you where you are finding the binomial coefficients using combinations. Okay, so let me write the formula first, NCR. So the formula says n factorial divided by n minus r factorial times r factorial. And I hope you remember from your lower classes that n factorial can be calculated by multiplying all the numbers which are n or less than n, and you decrease by 1. So n multiplied with n minus 1 multiplied with n minus 2 till you get 1. Okay, so that's how you calculate the factorial. Let's do maybe 2 parts out of this. B part you could try yourself. I'm going to be helping you for these 2. So let's do A part. 8C2. So I hope you all can compare. N is 8, R is 2 here. That means we are selecting 2 out of 8 combinations. So this formula, now you can substitute the value. N is 8, R is 2. So 8 factorial over 6 factorial multiplied with 2 factorial. Now how you simplify? There is a trick. The trick is the numerator you are going to expand using the factorial till you reach the maximum factorial in the denominator. So the maximum is 6 factorial out of 6 and 2. So I'm going to just expand till there. and then cancel out the common term. So 6 factorial always cancels to simplify this expression into this value. So the final answer is 28. So 28 is the binomial coefficient given by this combination 8C2. Okay, this is how we solve. Let's do the C part also. For the C part, n is 7, r is 0. So you can do 7 factorial over 7 factorial times 0 factorial. Now this is interesting. I hope you remember. What is the value of 0 factorial? It is 1. So that means this will cancel. So it is 1. Okay. Please try the B part yourself so that you are confident in calculating these combinations and using the binomial theorem. Just a hint, n is the big value, 10, r is 3 for this case. Okay, so let's take one last example on the binomial theorem where we are calculating the binomial coefficients and expanding. So this is right, the expansion of x plus 1 to the power 3. So here nothing is mentioned that you have to use a Pascal triangle or any other method. So let's go with the binomial theorem. So first of all, n is 3 here. Okay, the power is 3. So you can calculate the binomial coefficients using the combination formula as 3C0, 3C1, 3C2 or 3C3. If you want to use Pascal triangle, then third row of the Pascal triangle will give you the same binomial coefficients. So any method that you find easy, you can use for getting these binomial coefficients. Now the first term is x, the second term is y. So you do the same thing. You are using a plus b to the power 3 here. Okay. So first term will be raised to maximum power, second term to 0. Then the first term will be decreased, second term will increase, then A1, B2, and lastly A0, B3. And not to forget the coefficients which we've already got from Pascal triangle or the binomial theorem 1331. So this is going to be the expansion that we will use. Now you can just do the substitution. Your first term is x, which is a here, and your second term, which is b, is 1. So do that substitution in this formula for A and B to get your final answer on simplification as this. So this is the total final answer where you have got the binomial expansion of the term x plus y to the power 3. So I've explained you both the methods in this video where you can do the binomial expansion, find the binomial coefficients using the Pascal triangle or otherwise using the binomial theorem. If you like the video, don't forget to like, share and subscribe to my channel Mathematics Made Easy. Until then, this is Ms. Ruchika signing off from this video. Bye students.